Good morning, guys. Welcome back to another video. We're wrapping up things in terms of the semester. We got a couple more topics to go. Today, we'll talk about a topic that you may have seen before. I'm going to go out on a limb and say most of you have already seen it. It does show up a lot in pre-algebra, which a lot of you guys had in 7th, 8th grade. So we are still in chapter 9. We're in section 9.2.1, and we combine it with section 9.2.2 on solving linear inequalities. We know linear is something to do with lines. We know how to solve linear equations, so solving linear inequalities is really not that bad. First thing we should highlight is just the symbols. We do know the symbols for less than or equal to, greater than, and greater than or equal to. The first thing to keep in mind is that what makes it greater than or equal to versus just greater than? It's that little line underneath. So if you have the little line underneath, that's part of an equal sign. That means you could be equal to. We know that less than looks something like this, and then greater than looks something like this. When I was in middle school, I had a pretty good teacher who talked to me about this as a Pac-Man. I know from years past, students have said that maybe you guys have done something like a crocodile or alligator or something like that. So here you could easily think about like a Pac-Man. I was always told growing up that Pac-Man was really hungry. When you play Pac-Man, you always try to chase different fruits and collect all those dots. So whatever side that Pac-Man is facing is the bigger side. So in this case, if I had A and B, I would say B is greater than A because Pac-Man is facing the B. So I don't know if that's helpful, but I know that that helped me when I was learning it for the first time when I was growing up. So what is the first thing we need to do? In 9-44, we need to graph these inequalities on a number line. So what does that mean? Well, let's read what we have here. We have X, and then the Pac-Man is facing the X, so X is greater than or equal to -2. Now, we do know that X can be any number, but we're strictly saying it's any number that's bigger than or equal to -2. So how would you graph it? Well, you'd go to your number line, go to -2, and then we'll do this. We'll do a solid circle if it's included. We'll do an open circle if it's not included. So what do you guys think? Would -2 be included? Well, X could be bigger than or equal to -2, which means -2 is included. So it's going to be a solid circle. And then which way would you shade? Well, where are the numbers bigger than -2? The numbers that are bigger than -2 are to the right. So then you'll shade in this direction. I like to use kind of like a squiggly line and say that would be how you graph X is greater than or equal to -2. Quick way to check it. Pick any value here. What about 2? Is 2 greater than or equal to -2? It is. What about 3? It is greater than or equal to -2. Anything that's to the right side, also including -2, would make this statement true. So what do you think? How would you read a statement like this? X is less than or equal to +1. So what do you think? Is 1 included? Well, it is, because you're saying this mystery number could be less than or equal to +1. That means 1 could be a possibility, so close circle there. And where are all the numbers that are less than 1? Well, they're to the left. So then if you were shading, you would say all these numbers are less than 1. So I'd go that way. How about C? X equals 3. Well, then you can go to 3. It's definitely included. Which way would you shade? Well, for this one, you wouldn't shade at all. You're just saying X is equal to 3, and 3 is the only thing that is equal to 3. How would you read something like this? Well, that's X is greater than or equal to 0. Is 0 included? Yes, so we'll go to 0, solid circle. And then it says X is greater than because the Pac-Man is facing the X. So in which direction are X values bigger than 0? Well, to the right. So in this case, all of these things. So we can graph this way. How about X equals -2? Well, that's just -2 value, no shading because of equals. Again, these symbols are called inequalities. So if you want, you can write on your paper, these are inequalities. We know equals is just one value, where inequalities are lots of values. So now here we have something interesting in F. This is what's called a compound inequality. Why it's called compound is because compound usually means more than 1, usually means 2. So here we have 2 inequalities. So let's read this one first. We have -1 is less than or equal to X. Another way to say that, X is greater than or equal to -1. So is -1 included? It is. Now I'll say hold off on that one. How about the other one? We have X is less than or equal to 4. Is 4 included? It is. Now we said X has to be bigger than or equal to -1, so that would have to shade to the right. And then for 4, x has to be less than or equal to 4. That would have to shade to the left. So in this case, the shading would be in between these two things. Is that all the things between -1 and 4? Yes. So that means any mystery number less than or equal to 4 and greater than or equal to -1. How about this one? Here we have x squared is greater than or equal to 4. Well, what we could do is we could take a square root on each side. So in this case, you could say a square root on the left and a square root on the right. Then you would have x is greater than or equal to the square root of 4, which is 2. But then you'd also have x is less than or equal to -2. We know that -2, if you square it, is also going to be 4. So if x is bigger than or equal to 2, that means you start at 2. Would you shade to the right or to the left? You would shade to the right. That's where the numbers are bigger than +2. How about x is less than or equal to -2? Well, that means it could be -2. It could be everything less than -2, so anything to the left. So here, we would get something shaded like this. And last but not least, h, x is less than -3. So for -3, is -3 included? In this case, no. So you can do open circle on -3. You're saying x is less than, so in which direction would you shade to get x or numbers that are less than -3? You would shade to the left. So then I think your final will look something like this. All right, guys, so the first example, really nothing too crazy, just graphing on a number line. I'm pretty confident that most of you have seen this before. So if that makes sense, we can go to 9-46, and this is just going in reverse. If I give you a graph, can you tell me what the inequality is? So let's start with A. Well, notice there's a solid circle on 1. And then it looks like the shading, which is this heavier arrow, is being shaded to the right and then going in this direction. So I know it has something to do with x. I know it has something to do with 1. Again, x is the mystery numbers that we're trying to represent with the number line. 1 because we have a solid circle there. First off, would it be greater than or would it be less than? Well, I look at 1, I notice all things that are shaded are 2, 3, 4, and so on. That means it has to be greater than. My mystery number has to be bigger than or greater than. Pac-Man has to face it. And then what could it be equal to? Well, I see a solid circle. I know a solid circle means it is included. It could be equal to. This would be x is greater than or equal to +1. Let's go to B. I have an open circle on 1, and it looks like it's being shaded to the left. So again, start with x and start with 1. Would it be less than or would it be greater than? Well, I'm talking about numbers 0, -1, -2, -3, -4, and so on. So that means it has to be less than. Could it be equal to +1? In this case, no. I have an open circle, which means it's not included. So that means x is greater than or equal to 1 for A, and x is less than 1 for B. How about for C? Maybe you can pause the video real quick and try it here for yourself and see how it goes. Well, I have a solid circle on 3, and it looks like the shading is to the left. So then I would start with an x and a 3. I know that I'm talking about numbers like 2, 1, 0, -1, -2, and so on. So I know that the mystery numbers that I'm trying to represent are less than 3. Could they be equal to 3? What do you think? Yeah, they could be equal to 3. We have a solid circle there. So if it's included, that means it could be equal to it. X is less than or equal to 3. All right, notice in this last one we have something a little interesting. Kind of looks like what we had up in letter F on example 9-44. We'll start here. We have something with -4 and something with 2. So any times that you have 2 of the solid or closed circles, you can put x in the middle, put the smallest value to the left, which is -4, put the largest value to the right, which is +2. Now what can you tell me about +2? Well, we're shading to the left of it, so that means I'm shading things that are less than it. Could it be equal? Yes, because we have a closed circle. So in this case, you could say x is less than or equal to +2. But at the same time, notice it doesn't go forever to the left. It does stop at -4. Looks like from -4, we're shading to the right. So maybe you're familiar with this kind of a thing that I know other students in the past have said they've done that. Well, if we're talking about -4 and then we're trying to shade numbers like -3, -2, -1, and 0, then we're saying things that are greater than -4. Could they be equal to -4? In this case, no. We have an open circle at -4, so that means we'd have something like this. So how would you read that? You can say x is greater than -4 and x is less than or equal to 2. Or you could just go left to right. -4 is less than x is less than or equal to 2. Again, the Pac-Man, whichever way it's facing is the bigger side. So for example, right here, -4. And then the Pac-Man is facing the X, which means X is bigger than -4, which is basically the same thing as -4 is less than X. You see, guys, so it's really not so bad. I know most of you guys have seen this before, so it should not be too bad at all. Okay, let's keep rolling. So how about on the top of the paper, the next one, we see example 47, 48, 49 kind of all combined in one, and it's just solving inequalities. Luckily for us, solving inequalities is very similar to solving equations. The only thing you need to watch out for is if you divide by a negative, so maybe we should write it, is if you multiply or divide by a negative, then you flip the inequality. Okay, so it's really not so bad. Let's go to A. How would you get X by itself? Well, I see a -5, so in this case, I'll add 5 to both sides. So now I have 2X is greater than or equal to 8. How could you get X by itself? Well, I see 2 next to X, which means multiplication, so I'll use division to get rid of it. But here, notice I'm dividing by a +2, so I'll have X is greater than or equal to 8 divided by 2, which is 4. And since I'm dividing by a positive, I'm not flipping the inequality, I'm not changing the sign. My final answer is, how would you read it? X is greater than or equal to 4. And you could graph that if you want to, but in this case it just says, just solve for X. So how about B? Well, here I see 3 minus 2X is less than 1. So to get rid of the 3, I see a +3. I can subtract 3 to get rid of it. So now I have -2X. How would you read that? Less than 1 minus 3, which is -2. You see that? Now I see -2 next to X, which is multiplication, so I'll use division to get rid of it. So in this case, those will cancel. I have X, but I divided by a negative. We know that if we multiply or divide by a negative, we got to flip the sign. So instead of less than, now I have greater than. -2 divided by itself is 1, because anything divided by itself is 1. So in this case, the final answer for part B would be X is greater than 1. Again, you could graph it if you want, but we're just solving for X. All right, guys, how about 3X plus 1 is less than 7? Well, I see a +1, so I can subtract 1 to get rid of it. That means that 3X, how would you read it, is less than 7 minus 1, which is 6. I see 3 next to X, which is a multiplication. So let's use division to get rid of it. So now I have X, I divided by 3, so I don't need to flip the sign. So I have less than 6 divided by 3, which is 2. So final answer for this might be X is less than 2. So real quick question as a bonus for A, B, and C. Which one of these values is included in the solution? If you were graphing it, which one of these would have a solid circle instead of an open circle? Well, it would have to be this, right? When you're saying X is greater than or equal to 4, that means 4 is included. It's a possibility to be inside the answer. Where here, if you have X is greater than 1, that means that 1 is not included because X cannot be equal to 1. And then here, 2 cannot be included because X can't be equal to 2. So that's how you solve inequalities. Very similar to equations, guys. The only difference is if you multiply or divide by a negative, you have to flip the inequality. So what do we have for the math methods and meanings, the math notes? Inequality symbols. What does it say? Well, just as the symbol equals is used to represent that two quantities are equal in mathematics, the inequality symbols are used when describing relationships between quantities that are not necessarily equal. Could they be equal? Sure. They could be less than or equal to, they could be greater than or equal to, but they don't necessarily have to be equal to. So when graphing an inequality on a number line, such as X is greater than or equal to -1, a filled circle or a point indicates the value is a solution of the inequality, shown to the right. An open circle indicates the value is not part of the solution, as in X is less than -3, as shown in the right. So very similar to what we talked about on the front page. If you have a closed circle, that means it's included in the solution. It's part of the solution. Where if you have an open circle, it's not included. It's not going to be part of the solution. So in this case right here, we have X is greater than or equal to -1. So notice at -1, it's got a closed circle, it's included, and all the values that are bigger than or equal to -1 are to the right, or that value itself. Here we have X is less than -3. Notice on -3 there's an open circle, and we shade it to the left. Those are all the values that are less than -3, but not including -3. Okay, so there's a quick math note. The last thing we got to do is to solve some of these inequalities and then to graph them on a number line. So can we combine our skills and put it all together, guys, in 9-56? Let's do it. So how about an A? How would you get x by itself? Well, you see a minus 7, so to get rid of it, let's add 7 to both sides. If I add 7 to both sides, I'm not changing any signs because I'm not multiplying or dividing by any negatives. So in this case, negative 2 plus 7 is 5. So I have x is less than 5. So I go to my number line. On 5 itself, should 5 be included or not included? Would you do a solid circle or an open circle? Well, I would do an open circle because we know that if it's not equal to in the inequality, then it's not going to be equal to 5. Now, where are all the numbers that are less than 5? Well, how about to the left, right? 4, 3, 2, 1, any of the negatives. So in this case, I can shade in this direction. And we can set everything in this direction. You can also shade like this if you like. It's totally up to you. I like to shade with the wave, but you can shade like this as well, right? So what does it mean? That means that 5 itself is not part of the solution, but if I pick anything to the left of 5, it will make this statement true, right? If I pick 4, if I pick 3, if I pick 0, all of those numbers are less than 5. So how about B? How would you solve for M? Well, there are lots of ways to do it. One way to start would be, let's add 8. If I add 8 to both sides, I'd have to add 8 to this. It would be 3m plus 10 is less than or equal to 8m. To get rid of 3m, I see it's positive. I would have to subtract it from both sides. So now I have 10 is less than or equal to 8 minus 3, which is 5. 5 is next to m, which means multiplication, so I'll use division to get rid of it. But notice here, I did not divide by a negative, so 10 divided by 5 is 2. I don't have to flip the sign because I divided by a positive, and I'm left with m. So how would you read that? You'd read it as 2 is less than or equal to m. Now, what would be an exact way to say exactly the same thing, but maybe flip-flopped? Well, notice the Pac-Man is facing the M. So in that case, this Pac-Man still facing the M. I can write it this way, and I can make it still the same inequality, and 2 on this side. So notice I just reversed the entire inequality, but they are the same thing. If you're saying that 2 is less than or equal to M, that means that M has to be greater than or equal to 2. And I always like putting the variable on the left side. So now I know I have to start at 2. Is 2 included or not included? It's included, right? I have greater than or equal to 2. So would you do an open circle or a closed circle? I was hoping you'd say a closed circle. Again, how you read this statement is m is greater than or equal to 2. So which direction has values which are bigger than 2? Well, that would have to be to the right. So I like to do my waves. I'd set them up this way, make it very easy to see that this is the solution, right? It's 2 and everything bigger than 2, right? This mystery number has to be bigger than or equal to 2. It has to be greater than or equal to 2. So it's 2 and all the things that are bigger. Okay, guys, let's finish up. How about C? Well, to get rid of a negative 2, I can add 2. So here I have 2/3 P is greater than negative 4 plus 2 is negative 2. If you want, you can use your calculator for this part. So I see them next to each other, so you could say divide by 2/3. That could cancel off this. And it's positive, so then P is greater than. You could go to your calculator. You can put this 2/3 in parentheses. I think that will help. So then you can take negative 2, and you can divide it by parentheses, 2 divided by 3. All right, and you get negative 3. So I have P is greater than negative 3. So is negative 3 included or not included? Well, in this case, it's not included, right? There's no equals on my inequality. So not included means open circle on negative 3. How would you read it? P is greater than negative 3. My mystery numbers are bigger than negative 3. So which direction from this open circle are the numbers or the values bigger than negative 3? Well, to the right. So in this case, you could shade everything in this direction, all the things that are bigger than negative 3. Okay, hopefully this is going okay. Let's keep rolling here. I have 2 minus 3 to m's in parentheses x minus 1. So let's distribute this negative 3, right? So I have 2. Negative 3 times x is negative 3x. Negative 3 times negative 1, positive 3. Greater than or equal to x minus 7. So let's use some of our skills. Well, we can combine 2 plus 3. This would be 5 minus 3x is greater than or equal to x minus 7. We can add this 3x over. Again, lots of ways to solve. We can do it this way though. 5 greater than or equal to, what's 1x plus 3x? Well, that would be 4x minus 7. How would you get rid of minus 7? You could add it to the other side. So I'm going to put my work right here. 5 plus 7 is 12, greater than or equal to, and then this is 4x. I see 4 next to x, which is multiplication, so I'll use division to get rid of it. 12 divided by 4 is 3, greater than or equal to x. I didn't flip the sign because I divided by a positive, but again, I like having my variable on the left side. So here you would read 3 is greater than or equal to x, but what's exactly the same thing? If 3 is bigger than or equal to x, that means that x has to be less than or equal to 3. Again, look at the Pac-Man, right? The Pac-Man is facing the 3. So if I flip-flop the order, then Pac-Man is still facing the 3. So I like it like this, right? So I know I have to start at 3, but is 3 included or not included? Well, since x is less than or equal to 3, it's included. It's going to be a solid circle. But where are the values that I'm talking about here less than or equal to 3? Where are they less than, to the right or to the left? Well, things that are less than 3 are like 2, 1, 0, and all the negatives. So that means that all these values to the left here are going to be the values that I'm interested in. So that's where the shading is going to be. All right, can we finish these last two on the bottom here? So the last two on the bottom, let's see if we can wrap them up, right? So first things first, I want to combine things on question E. So I have 9k minus 4 plus 1. Well, negative 4 plus 1. So it'll be 9k, negative 4 plus 1 is negative 3. Can I combine anything on this side? Well, I have 2k and 7k, which is 9k. And then minus 3. If you want, you can subtract 9k from both sides. Those will actually end up both canceling. And you have negative 3 is less than or equal to negative 3. And a lot of people at this step will think that they did something wrong. What do you think? Well, check the validity of the statement. Is the statement true or false? Is negative 3 less than or equal to negative 3? Well, negative 3 isn't less than negative 3, but it is equal to. So because this has an equal to, that means that this statement is true. This means that any value of x that you pick, this statement is going to be true, regardless of what you pick. So if it's true, and it doesn't matter what x value I pick, it's always going to be true. That means that all real numbers is my solution. So how would you graph something with a solution of all real solutions or all real numbers? Well, if I can pick anything for x, that means that the entire number line is the solution. So what I can do is I can say the entire thing, right? I can pick any x value I want, and it's going to make this statement true. I can pick a positive, I can pick a negative, I can pick 0, I can pick a big positive, a big negative, a really small one. It doesn't matter. If you get a true statement and there are no variables left to solve for, that means that you have all real solutions, very similar to what we used to do with systems. So maybe some of you guys recognize that solution. How about f? Well, maybe the first thing you would say is subtract 3y from both sides, but you'll notice very similar to e, that those will cancel and you're left with 1 is less than 1. So now you have to check the validity of the statement. What do you think? Is 1 less than 1? Well, no, that's very false. So if it's false, that means there is no x value which will make this true. Any x value that you pick will never make it true. So what does that mean about the solution? That means that there's no solution. How do you graph no solution on the number line? Well, if no value of x is going to make this true, that means there's no value of x here that I can shade in order to make it true. I can't represent the solution if there is no solution. So that means the number line is going to be left blank. And I always tell students to write blank underneath it, just in case you thought you missed something, or maybe you think you were spacing out or something like that. So in this case, if you have a true statement with no variables left, that's all real solutions, the entire number line, every x value that you can think of. Or in the case you have something that doesn't make sense, that's false, that means there's no solution, the number line is blank, and there are no values of x that are going to make the statement true. Or in this case, no values of k. Okay guys, so what's the big idea here? Well, we solve inequalities just like equations. We know that if you multiply or divide by a negative, you got to flip the inequality. We do know that inequalities means that things don't necessarily have to be equal. Could they be equal? Sure, but they could also be less than and greater than. And then last but not least, do we know how to graph inequalities? Do we know how to represent them? Again, they're just saying that's all the values that are bigger than or less than or bigger than equal to, less than equal to some value. And then can we go in reverse? If I gave you a graph, could you write the inequality? I think so. All right, guys, that's it for the video. It's kind of a fast one today. Thank you for watching. If you could complete the assignment and upload to Canvas as usual, I would really appreciate it. Again, thanks for watching the video, and have a great day. See you guys.